So in this section, we're going to go over 11.6 on systems of nonlinear equations. So let's go ahead and solve the following system of equations. X squared plus y squared is equal to 25, and y squared equals x plus 5. So these two equations are not linear. The first one is a circle, and the second one is a parabola. So we're going to go ahead and find where these two equations intersect. So we're going to go ahead and solve the system. In order to solve the system, what we're going to do is we're going to go ahead and use substitution. So I have y squared equals x plus 5, and I have a y squared in here. So I'm gonna plug in this y squared into the y squared in the first equation. So I'm going to take the x plus 5, plug it into the y squared in the first equation. So again, I'm going to take that second equation and plug it into the first. So we had x squared plus a y squared originally. We said now that it's x plus 5, and this is equal to 25. So in order to solve it, we can go ahead and, because it's a quadratic, we can try to factor. So this is x squared plus an x, subtract the 25, you get minus a 20 is equal to 0, and then factor this. So this becomes x plus 5 times x minus 4. So we're looking for two numbers that multiply to negative 20 and add to a positive 1. That's 5 and negative 4. And this is equal to 0. Set each of these factors equal to 0. X plus 5 equals 0. X minus 4 equals 0. That means that x equals negative 5 and x is equal to 4. So let's go ahead and find the y values for each of these. So to find the y values, you can either use the first function or first equation or the second equation. So let me go ahead and find the y for x is equal to negative 5. And in order to do that, I'm actually going to go ahead and use that second equation. Y squared equals x plus 5. So that's negative 5 plus 5, and this gives me back a 0. So that means that y is equal to plus or minus the square root. Because I have a square, in order to get rid of it, you take the plus or minus the square root. So plus or minus the square root of 0 is equal to 0. That means that when x is equal to negative 5, y is equal to 0. Do the same thing for x equals 4. So plug in x equals 4 into the second equation, you get y squared equals, it used to be x plus 5, now the x is 4, so 4 plus 5 is equal to 9. That means y squared is equal to 9, which means that y equals plus or minus square root of 9, which is plus or minus a 3. So that means that when x is equal to 4, y is equal to 3, and when x is equal to 4, y equals negative 3. So then my intercepts, or my point of intersection are negative 5, 0, 4, 3, 4, negative 3. But we actually have to double check that all of these are actual points of intersection. So when you have a system of nonlinear equations, we need to go and check these solutions. So in order to check the solutions, what we do is we plug them back into both equations. So if I want to check it, or check them, I'm going to go ahead and check negative 5, 0, and I'm going to do so in the first equation. So in the first equation, it was x squared plus y squared is equal to 25. So now x is equal to negative 5, y is equal to 0. So that means that negative 5 squared plus a y squared, which is now 0, squared is equal to 25. So we're checking to see if the left is equal to the right. That means in this case 25 plus a 0 squared is equal to 25, so this one checks off. And then you also want to check it in the second equation. So y squared equals x plus 5. So here I'm going to check it in x squared plus y squared equals 25. And then I'm also going to check in y squared equals x plus a 5. So y is equal to 0, so we're going to check is 0 squared equal to negative 5 plus a 5. And 0 is equal to 0, so then this is true. And now I'm going to go ahead and check for 3. So for 3, if I check it in the first equation, 4 is the x value, so 4 squared plus y squared, that's a 3 squared, is equal to 25. So 16 plus a 9 is equal to 25, so this is true. And then you want to check it in the second equation also. So y squared is 3 squared equals x plus 5, x is 4, and we're checking to see if the left is equal to the right. Don't move anything from the right to the left or from the left to the right. So leave everything that's on the left side, leave everything that's on the right side, and check to see if the left is equal to the right when I simplify each of the sides separately. So for 4, -3, plug in a 4 for the x and plug in a -3 for the y. So in the first equation, I'm going to get 4 squared plus a y squared, so plus a -3 squared is equal to 25, and just like before, 16 plus a 9 is equal to 25, so this is true. And then in the second equation, y squared, that's -3 squared, is equal to x, that's a 4 plus a 5, and that's 9 equals a 9, so this is true, which means that all of my solutions checked off, which means that all of these are actual answers. So what does this mean graphically? Let me go ahead and go back to the graphs of these two equations. So in the first equation, we said it was a circle. This is actually a circle with the radius of 5. So if I draw a circle with the radius of 5, let's go ahead and go 5 to the right, 1, 2, 3, 4, 5, 5 up, and then 5 to the left, and 5 down. So we're going to go ahead and draw a circle that's at a center of 0, 0, and has a radius of 5. So this is my circle with a radius of 5 and also centered at 0, 0. And then y squared equals x plus 5. So this is in the form of y minus k squared equals 4a times x minus h. So if I use this form and I match it to this equation, the k is actually equal to 0, and the h is actually equal to -5. So that means that my hk, or the vertex, is at -5, 0. So -5, 0 means that this parabola is going to have a vertex at this point. And this opens to the right. So this parabola opens to the right because if 4a is actually positive, that means it opens to the right. So for the rest of it, for the rest of the parabola, you can go ahead and find the y-intercepts in order to determine how much to go up and how much to go down. But now I can go ahead and just use my intersection points to go ahead and plot the rest of it. We know that these two graphs are going to intersect at -5, 0. We can see that at this point, and then 4, 3, and 4, -3. So we go 1, 2, 3, 4 to the right, and then 3 up, and that would be this point here. And then for -3, you go 4 to the right and -3, so 3 going down. So that means that my parabola is going to also go through those points. Let's go ahead and do another example. So on this one, let's go ahead and solve the system of equations given by x squared minus y squared is equal to 4 and y is equal to x squared. So on this one, this is a hyperbola and the second one is a parabola. So for this hyperbola, we're going to go ahead and divide all of the sides by 4. So if I divide everything by 4, I get x squared over 4 minus y squared over 4 is equal to 1. That means that a is equal to 2, b is also equal to 2, and then my hyperbola is going to also be centered at 0, 0. So the center is at 0, 0. Then you go 2 to the right, and then 2 to the left. So it starts with an x, that means I'm going to go 2 to the right and 2 to the left. It opens left and right. And then my points, my two vertices, are at -2, 0 and at 2, 0. And again, it opens to the right side. If I use this b value, if I go 2 up and then 2 down, it's going to give me the rectangle, the fundamental rectangle. So I can go ahead and draw my box using a and also using b, and then also draw your asymptote through the opposite sides of the rectangle, so through the diagonals and also through the center, and this is going to help guide me to draw the hyperbola. So I'm going to go ahead and draw it facing to the right and then also facing left. And then for this second equation that we have here, we have y is equal to x squared. This is just a parabola. So this parabola is centered at 0, 0, or the vertex is at 0, 0. And then it goes through 1, 1, negative 1, 1. It goes through 2, 4. So go 2 more. And if you notice, these two actually do not intersect. So the hyperbola and this parabola do not intersect. So when I find the solution, I should actually find that there's no solution. Let's go ahead and check that. So when you actually go and when you actually go and solve these, you don't actually have to graph them, but I wanted to see it visually first. So let's go ahead and do substitution just like on the previous example. So we get x squared minus a y squared is equal to 4. So I'm going to use that first equation. What I'm going to do is I'm going to plug in a y wherever I see an x squared. So I see an x squared here, and this is x squared. We said we're going to take the y and plug it in to that x squared. So I'm going to go ahead and plug in a y minus a y squared is equal to 4. So again, I substitute in this x squared with a y. And then I'm going to go ahead and simplify this. So this is another quadratic. And if I move everything to the right side, I'm going to get 0 equals y squared minus a y, and then plus a 4. So I moved everything to the right, added a y squared, subtracted a y. And then I'm going to go ahead and try to factor this. So I can't find two numbers that multiply to 4 and add to negative 1. So what we have to do is use a quadratic formula. So you can either complete the square or use a quadratic formula. So I'm going to use a quadratic formula, y equals negative b. So negative of negative 1 plus or minus the square root of b squared. B is negative 1, so negative 1 squared minus 4 times a times c. A is equal to 1 and c is equal to 4. All over 2 times a, so all over 2 times 1. So if I simplify this, I get 1 plus or minus square root of negative 15. So if I simplify the inside here, I get negative 15 all over 2. Well, because there's a negative inside of the radical, this would be a complex number. We don't graph complex numbers, so for this one, there's going to be no solution. So usually when you have any equations, any system of equations that's nonlinear, the go-to would be substitution. And then once you find the solutions based on this substitution method, what you want to do is always check your answers. So for any system of nonlinear equations, make sure that you always check your answers to see if they really are answers. So check your solutions to see if they really are answers.